This is 2026 Cayley, Part C. Verse 21. In the diagram, each of the four circles has radius 8 and is tangent to two other circles. The centers of the circles are the vertices of the square. To the nearest integer, what is the area of the shaded region enclosed by the four circles? This one is really easy. You just need to first you draw the four circle, and then the shaded region is here. The center is here, 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 here. Connecting them, passing through the four tangent points, and you will see this part, this part, this part, and this part plus together become a full circle. So the only thing to do is the area of the square minus the area of a circle. So what we'll do is 16 squared minus a squared pi, and we'll approximate value 54.94, which is close to 55 for the first answer, 21. Second, of the 100 people who are watching a movie, 47 bought popcorn, more than 40 bought a drink. X bought both popcorn and a drink, and 2x bought neither. If x bigger than 0, what is the largest possible value of x? Okay, we just need to list, first of all, we list all the things we know. There's 100 people here, and among the 100, there are 47 of them bought popcorn. Bigger than 40 has a drink, and x bought both, and a y, no, 2x is neither. Okay, so through things we can say, oh, 47, we say this, the people bought drink, we say this is y. 47 plus y plus 2x for neither, and then minus x for the overlap, and this should equal to 100. So we want to maximize the x, so we want to minimize y. So the minimum value of y is 41, so we do 47 plus 41 plus 2x minus x, which is plus x equal 100. After some calculation, we see x equal 12. And this is answer. By trying x equals 13, we can see that when x equals 13, the total people will become 101, which is bigger than 100, which is impossible. Okay. For some distinct positive integer p, q, and r, the integer 2r minus 21 with 3r minus 1, r plus 12, and 3r minus 17 are equal to the integer p, 2p, q, and 2q, but not necessarily in that order. What is the sum of all possible values of r? So, first of all, we observe p, q, and r are integer, which is in z, and 2r minus 21, 3r minus 1, r plus 12, and 3r minus 17 is equal to the sum of p plus 2p plus q plus 2q, which is, so this means 2r minus 21 plus 3r minus 1 plus r plus 12 plus 3r minus 17 equal to 3p p plus 3q. After some simplification, we see left side equals 9r minus 27, right side equals 3 bracket p plus q. Divide 3 on both sides, we'll get 3r minus 9 equal p plus q. So 3 times r minus 3 bracket equal p plus q. Okay. And right now, we see here 2p and 2q. Since p and q are positive integer, 2p and 2q should be the biggest among the four. So this means while matching them up with 2r minus 21, 3r minus 1, r plus 12, and 3r minus 17, we should choose two integer that is biggest among the four. So we first analyze the data we get. We can see that 3r minus 1 is bigger than 3r minus 17, bigger than 2r minus 21. And for the r plus 12, we're not sure. Okay. Based on this, we can start to analyze them based on several cases. First case, we say 2p and 2q is 2r minus 21 and 3r minus 1. So we just say 2r minus 21 is bigger than r plus 12 and 3r minus 1 is bigger than 3r minus 17. So this is the only case for 2r minus 21. We can say it might be the biggest number. Otherwise, it's impossible, because 2r minus 21 is always smaller than 3r minus 17 and 3r minus 1. The only number could smaller than is r plus 12. Okay, so let us solve it. So we get 5r minus 22 equal to, since we're doing 2p plus 2q, so which means for the previous one, 3 times r minus 3, we should times 2. 2 times 3 times r minus 3. So we get 6 bracket r minus 3. So move 5r to the other side, so we get r 6 times 3 equal 18, 18 to the other side. 18 minus 22, which we get minus 4 equal r. But r, we say at the beginning, is positive integer. So the first case is impossible. Second case. We say 2p and 2q might be 3r minus 1 and r plus 12. So in this case, 3r minus 1 is bigger than 2r minus 21, bigger than 3r minus 17, and r plus 12 can also could be bigger than 2r minus 1 and bigger than 3r minus 17. So let's try first to solve r and see what's going to happen? So 4r 3r minus 1 plus r plus 12 equal 4r minus plus 11 and which is equal to 6r minus 3. So 11 plus 18, which is equal to 2r. But as you can see, right now we get 29 equal to 2r. And 29 over 2 is no longer an integer. So the second case is also impossible. Yeah. So we come to our third case where 3r minus 1 and 3r minus 17 might be the two biggest. So we get 6r minus 18 equal to 6 bracket r minus 3. And we can see both sides are equal because the other side, which is equal to 3r minus 18. So which means in this case, it might be we might find a possible value for r. So we substitute into the cases. So we assign 2r minus 21 and r plus 12 to them. So small case 1, so 3r minus 1 equal 2p and 2r minus 21 equal p. And then, so we say 3r minus 17 equal 2q. R plus 12 equal q. So we solve it. We can see this side is which is equal to r minus 1 minus minus 21. So we get r minus the r plus 20 equal p. Wait, 3r minus 1. Oh, wait. But because we want to cancel out p, actually this way is not good, not a really good method. I should do 2 times 2r minus 21 equal to 3r minus 1. And we solve it, we find 4r minus 42 equals 3r minus 1, and we get r equal 41. And this side is the same, so we should obtain the same answer. So we get 2r plus 24 equals 3r minus 17. So go to our goal, so left with r, 17 plus 24, which is 41. So 41 is correct. And we say consider our second smaller case. With 3r minus 1 still equal 2p, but this time p is equal to r plus 12, and 3r minus 17 is still equal to 2q, but q this time is equal to 2r minus 21. So let us solve it. So 2 times r plus 12 equal to 3r minus 1. So 2r minus plus 24. So 2r gone. So only I have left with 1r. So 24. 24 plus 1, so 25. 25 equal r. And we look at the other side. So 4r minus 42 equal to 3r minus 17. 3r goes to the other side, so left with r. And the 42 go to the other side, 42 minus 17. What we get? So also 25. So 25 equal r is also correct. So after seeing this, we consider our last big case, case 4, where r plus 12 and 3r minus 17 are considered as the two biggest numbers. So we solve it. So r plus 12 plus 3r minus 17 equals 6r minus 3. So 4r minus 5 equals 6r minus 18. So 13 equals 2r, which is impossible since r has to be positive integer. So the only two we find is 25 and 41. So we get 66. This is our answer for question 23. Okay, the question 24 is, I consider is quite easy. So in a 6 times 6 times 6 cube shown, C and F are vertices, and A, B, D, and F are midpoint of their respective edges. The intersection of AF and EC is G, and the intersection of BF, DC is H. A piece of cube is removed by slicing it through the plane ABF, and then another piece is removed by slicing through the plane EGHD. This process is repeated on each of the 4 vertical edges of the cube. Let V be the volume of the remaining piece of the cube. What's the rightmost 2 digits of V? Okay, this one is quite simple. Why? Because if you're doing things like this, we can see ABF triangle and triangle EDC is similar. Why? Because as you can see, they have the same base and the same height, and the length for the 3 sides is same, but they are just flipping around. Meanwhile, we can see CG triangle ACG is similar to triangle GEF because EF is equal to AC, and since this is a cube, AC is parallel to EF, so which means angle ACE is equal to angle CEF. This is same for the angle CAF and angle EFA. So this means JE is equal to length CG So EG equal to CG. So this means CG is equal to 1/2 EC. Same thing for AF and GF, HF and BAF, CH and CD. Okay, so right now the only thing we need to do is we just need to find out the prism of EFDC and reduce the part above G and times 2, then we can find the result. So based on what we learned, we know if every side length is half, then the volume will be reduced by 1/8. So this means originally this one should become 3 times 3 times the height, which is 6, times 6. Then over 2 because the base is a triangle. Then over 3 because it's a prism. So we get 9. And then we reduce 1/8 of its parts, so minus 1/8, which is equal to 71/8. And then times 2, we get 71/4, which is one vertical edges. 71/4 times 4 edges, which we get 71. And then we use the entire volume of the square cube minus 71, we'll receive our final answer, which is 256 minus 71, which is equal to 585, 185. And that is our solution. Let me double check the calculation. 6 times 6 times 6. Okay, my bad. Because we can see that triangle ABF is similar to triangle EDC. Meanwhile, triangle ACG is similar to triangle GEF because they have the same base, AC equal to EF. And since AC is parallel to EF, so angle ACG is equal to angle FEG. Angle CAG is equal to angle EFG. This is also applied to triangle CBH and HFD. So this means CG is equal to GE and AG equal to GF. So this means C E is equal to 2CG. This also applied to CD, AF, BF. Okay. So right now we only need to calculate the prism CEFD and then reduce the top part GCH, the top part above G and H. Okay. So what we do is first we find out the volume of this prism. So base times height over 3. So base here is 3 times 3 over 2. Then times height 6. Then over 3. We get 9. And since every side length is reduced by is shortened by half, so this means we say the smaller prism that are above the smaller prism top part is 1/8 of the bigger one, because 1/2 times 1/2 cube, right? So 9 times 7/8 is remaining, but since on one vertical edges there are 2 like this, so 2 times 7/8 times 2, and then times 4 for 4 vertical edges times 4, so we get 63. And then we just need to do 6 cube minus 63, and then we get 216 minus 63, which is 153. So we get 53 as our answer. Okay. 25. So the consecutive integer from 1 to 2k are written in order. Author erase k consecutive integer from this list. The remaining integer have a sum of 819, with the sum of all possible values of k. First, we need the sum of value from 1 to 2k. So 1 to 2k, 1 to 2k, which is 1 plus 2k over 2 times 2k. So after simplify 2 and 2 go, we get 1 plus 2k times 2 times k. And for the value for the k consecutive integer from this list, we say the first integer we choose is x, where x is bigger or equal to 1, but smaller and equal to k plus 1. And x plus k minus 1 over 2 times k, which after simplify we get 2x minus plus k minus 1 bracket over 2 times k. So we subtract this value from this one and we expand it, we get k plus 2k squared minus bracket 2xk plus k squared minus k over 2 bracket equal 819. So we times 2 on both sides and combine them, we get 3k squared minus, no, plus 3 minus 2k, 3 minus 2k, 2x k equal to 1638, 1638. Okay, we see it looks like quadratic, but when we try to use quadratic, we'll see the delta will become since delta should be equal to 0, no, but there's nothing can clamp the value of x, so which is useless in this scenario to use a delta to find the value of x because the inefficiency and the difficulty minus plus 4 times 3 times 1638 to be something integer, to be something k squared, no, I should say c squared, which is too hard. Instead doing that, we just analyze this expression, this equation by factor it. So k times 3k plus 3 minus 2x equal to 1638. So because of this, x is smaller or equal to k plus 1. For 2x, this means 2x is smaller or equal to 2k plus 2. So this means 3k plus 3 minus 2x is bigger or equal than 3k plus 3 minus 2k minus 2, which is bigger or equal to k plus 1. This means this part is always bigger than k, since 1638 is not a perfect square, so which means the two numbers we factored out is always one larger and one smaller. So based on this, we can see 1638 can be factored into two numbers, which is 1, 1638, 2, 819, 3, 546, 6, 273, 7, 324, 9, 182, 13, 126, 14, 117, 18, 91, 21, 78, 26, 63, and 39, 42. Okay, but based on our previous one, so 3k plus 3 minus 2x bigger than k, we can see if we say 3k plus 3 minus 2x equal to 3k plus 3 minus 2k, move the 2x, yeah, move the 3k plus 3 to the other side, and times minus 1, we get 3k plus 3 minus 3k plus 3 minus 2x, which is equal to 2x up to times minus 1. This part can be simplified to 3 times k plus 1. So this means if we triple the smaller number and plus 3, it should exceed the original bigger number. And by observing all of this number we list, we can see the only two that apply is these two. So our final solution for this question is 26 plus 39, which is 65. Yeah, thank you.